All right, welcome to the second video on the rules of exponents. Here with this video, we are going to kind of increase the rigor that's going on and the difficulty of the problems. So please make sure you're following along, you're taking notes. As you're going to notice on this very first problem, we have exponents on variables with coefficients. And this is what's going to kind of add a little bit to what we're doing. So please pay attention, follow along. We've got, and then we've got a couple of new properties here that we're going to talk about. All right, so just like before, this is very similar, but we get a little confused here because now what you see here is we have 3 and 4. Those are called coefficients. They are numbers that multiply the variable. Now, they both have an exponent of 1, okay? But we're not going to really deal with them in the same way we've been dealing with the other numbers that we've seen when we've had things like 3 to the 5th times 4 to the 2nd. Here, when we had that, we were not combining those and making 12 to the 7th. Okay, not 12 to the 7th. That's bad. Okay, so what we really want to kind of think about here is when we just have a coefficient, what can we do with that? So I'm going to reorder things. And we're going to have 3 times 4 times n to the 4th times n to the 7th. So here, we can deal with the 3 times 4, and we can deal with the n to the 4th times n to the 7th. Let's talk about 3 times 4. We've just been talking exponents. Sometimes after we do that with kids, they kind of forget just their normal math. So 3 times 4 is just 12. And it's okay to just do that. Okay, if you look over here, what I have written up here, the 3 to the 5th times the 4 to the 2nd, we can't make that 12 to the 7th because those aren't the same bases. But when we have an exponent of 1, we can just multiply them like we've always multiplied. And then with the n to the 4th, n to the 7th, still think about our expanded form and condensed form. If we were to expand that all out, I'd have 4 n's, and then I would have 7 n's, so I have 11 n's. It's just like this example here at the top, product of powers, that we've kind of been working on. Okay, it's this same example, but now we have got variables involved in it. So we could have like x squared times x to the 3rd equals x to the 5th to add an example up there. Okay, so these are examples where we are also adding our exponents. So now in the second example, I'm going to rewrite things that are next to each other. The other thing I want to say is, do you see between this x and the y here? There is a multiplication sign, though it's not written. These terms are being multiplied. Whenever we have two variables next to each other or a coefficient in front of a variable, there's multiplication that's happening. So I can rewrite this as 7 times 2 times x squared times x to the 4th times y cubed times y. Now, we have 3 distinct kind of things going on here that we have to think about. So 7 times 2, 14, okay? There's no exponents here. We're not thinking exponents. We're thinking coefficients. Just multiply the two numbers. X squared times x to the 4th. What I'm thinking is I have 2x's and 4x's, so I have 6x's. And then always remember, we got a 1 on that y. So that is going to be y to the 4th. Okay, so this is a little bit of a step up from where we were at last week. Again, we're going to work on this all week. Just stick with me. Now, here with power to a power, we have power to a power, and we have a 7 here. Okay, so 7 to the 1st. So, if we remember from power to a power, when we have power to a power, we multiply. So here we're going to multiply these things. And it's the same thing if I have x squared to the 3rd. This is now x to the 6th, 2 times 3. So here I'm going to take all 3 of my exponents and multiply them by 3. So I'm going to have 7 to the 3rd, x to the 18th, y to the 15th. Now, last week, we would have just left 7 to the 3rd and moved on. But this is kind of one of those annoying mathematician things. When we have variables and we have a coefficient, we like to know what the coefficient actually is. So here we are actually going to go to our calculator and we're going to calculate what is 7 to the third. So 7 to the third is 343. So we're going to have 343 x to the 18th, y to the 15th. Now, these two items, the first line and the second line here, they're equivalent expressions. They're both equivalent to our original expression, but our most simplified answer per mathematician needs to be this last one. All right, so let's look at this next one. On the right, same idea. I see a power to a power. Okay, this 2 has an exponent of 1. So it's going to become 2 squared x to the 4th, y to the 6th, times x to the 3rd, y to the 4th. Now I can go ahead and reorder things. 2 squared, x to the 4th, x to the 3rd, y to the 4th, y to the 6th. So those are all the terms. And now as I go to simplify this, I know that 2 squared is 4. X to the 4th times x to the 3rd would be x to the 7th. And then y to the 10th. Okay, so again, step up here. Stick with me. Okay. All right, what did we do before with division of numbers with exponents? We subtracted. Okay, we subtracted. So if we go back up here, if I have x to the 7th divided by x to the 3rd, just like before, this is going to equal x to the 4th. Doesn't matter if it's a variable, if it's a whole number, whatever it is, it behaves the same way. So now, as I look at this problem, I'm going to use some highlighting. I see the coefficients that need dealt with, the x's that need dealt with, the y is kind of by itself, and then the z. So every one of these things needs dealt with differently. Now, 72 divided by 24. Am I completely sure what that is off the top of my head? I don't know. Let's go to our calculator. 72 divided by 24 is 3. How about that? So, whoops. So this is going to equal 3. Now, with my x's, I need to subtract. 5 minus 3 is 2. The y has nothing to change it, so it just comes along, y to the 7th. And then the z's, we have 10 minus 5 is 5. Now, you're all going to ask why I write my z's like that. I write my z's like that so they don't look like 2's, okay? It's the same reason why I write my 7's with a line across it so they don't look like 1's. It's just a clarity thing. If you notice, my 2 and my z without that little line would look very similar. So I write that so that a little bit of clarity. All right. Now, this is where we're really going to take this step up and talk about something new, okay? We're going to talk about what happens when we end up with y's, numbers, and variables on the bottom part of a fraction. Okay, and this would work for numbers too. So I want to remind us that x to the 4th over x squared would be x times x times x times x over x times x. Whoops. And what we're going to do is we're going to cancel and cancel. We're left with 2x's, which is x squared. That makes sense. 4 minus 2 is 2. Now, here, let's talk about this. I'm going to expand these y's out. Y times y times y times y times y over y times y times y times y. Sorry, I got to get to 7 here. I think that's 7. 1, 2, 3, 4, 5, 6, 7. Now I'm going to start crossing off pairs. That's weird. There's 2 left in the bottom of the fraction. What's left in the top of the fraction is a 1. So what I have is I have 1 over y squared. Well, if I were to do subtraction here, I would have y to the 5 minus 7, which is y to the negative 2. So this is equal y to the negative second power. So when we have a negative power, what that indicates for us is actually that power needs to be in the bottom part of a fraction. So if it's not there, we put it there. Okay, so this is where this rigor level really kind of increases. Okay, so stick with me. I promise by the end of the week, you'll have some understanding about it. All right, let's look at this here. We have z to the 5th divided by z to the 5th. Well, what's anything divided by itself? 1. 5 divided by 5 is 1. 10 divided by 10 is 1. Well, what though is, if I had z to the 5 minus 5, that's z to the 0. So what we've just done, actually this is kind of a mathematical proof, honestly, is that z to the 0, or anything to the 0 power, is equal to 1. That's called the zero exponent property. Okay? So we've added a couple of properties here. We're going to do 3 quick examples with negative exponents. Again, a negative number is a number like any other number. Please don't freak out about it. Okay? But what we're going to do with that negative number is we're going to send it to the bottom of our fraction. So let's go ahead and look at this next example. Okay, we've got 75 divided by 3. Well, 75 divided by 25, that's 3. And then the next thing to deal with is a cubed divided by a to the 5th. So what we have is a to the 3 minus 5, which is a to the negative 2. Okay, there are more a's on the bottom, so we're going to end up with a negative number, 3 minus 5. And then we are going to deal with the b's. So 10 minus 4 is 6. But again, mathematicians are weird. We don't like negative exponents. So anything with a negative exponent must go to the bottom of a fraction. Well, you might be saying to yourself, Mr. Saffel, there's no fraction here. Well, let's make one. So we're going to leave everything in the top that has a positive exponent and put everything in the bottom that has a negative exponent, and then change that exponent to positive. So this is our most simplified answer. Okay, this next one's weird. Well, I'm going to rewrite some things. So 2 times 3 times c to the negative 5th times d squared. Well, 2 times 3 is 6. And then d squared can stay in the top. But this negative 5's got to go away. So we got to put that in the bottom. So that's our equivalent answer. 6d squared over c to the negative 5th. Or sorry, c to the 5th. All right, one last question here. I'm going to rewrite some things. 5 times 3 times x squared times x to the 5th times y to the negative 5th times y to the 3rd. All I did there was rewrite things in different order. Now, I have pairs of things that I need to think and deal with. So 5 times 3, big numbers, coefficients, 15. Here we add our exponents. X squared times x to the 5th would be x to the 7th. Here with the y's, we add our exponents. Negative 5 plus 3 is negative 2. Guys, if you struggle with your mathematical operations involving negative numbers, please use a calculator. So we end up with y to the negative 2nd. But mathematicians do not like negative exponents. So we need to send that negative exponent to the bottom of a fraction. So 15x to the 7th divided by y squared. Once it goes to the bottom, we make it positive. Okay, well done. This is hard. Stick with me. Okay, this is really, this year, the hardest, most complex thing we have done.